There is a salt sitting in the ice melt aisle of every hardware store in America right now that can pull more heat out of a humid room, pound for pound, than the refrigerant inside your air conditioner. Not a rare earth, not a patented chemical. Calcium chloride, a specific industrial salt that absorbs over 400 BTUs per pound of moisture from the air, while its own temperature barely climbs at all. In 1902, a 25-year-old engineer in Buffalo used it to build the world's first modern air conditioner at a Brooklyn print plant. Today, the National Renewable Energy Laboratory uses the same chemistry to cut commercial cooling loads by double digits with zero refrigerant. And yet, in America, you cannot buy a house that uses it. Not one major builder offers it. So here's the question this video answers. If a $15 bag of road salt can do the work of a compressor, who decided you would never find out? Let's trace it back. Long before anyone wired a compressor into a wall, people were using salt to strip heat out of the air. And they were doing it on purpose, with precision, on 3 different continents. Start in medieval Spain. Court records from the 14th century describe Andalusian apothecaries lining storeroom walls with shallow trays of rock salt to keep precious herbs dry through brutal summers. Visitors described walking in from a 95-degree street and feeling the air drop the moment they crossed the threshold. The salt was doing the work of a machine that would not be invented for 500 years. The Mughals worked the same physics from the other side. Royal physicians of the 16th century packed bowls of coarse mineral salt into the niches of sleeping chambers. The salt absorbed the humidity. The body could finally cool itself. And in 17th century England, ship captains lined cargo holds with bags of calcium-rich salt. Dock workers noticed the holds were measurably cooler than the deck above them. The salt was supposed to dry the air. It was doing something more. Different empires, different centuries, no contact between them. And every one of them arrived at the same answer. Certain salts, when they pull moisture from the air, swallow enormous amounts of heat from their surroundings. The knowledge was never lost. It sat in apothecary ledgers and naval logs for 400 years, waiting for someone with a laboratory to turn it into a machine. In 1902, someone finally did. And then he buried it. His name was Willis Haviland Carrier, a 25-year-old engineer fresh out of Cornell, working for the Buffalo Forge Company. By the 1920s, the press had already given him a nickname, the father of air conditioning. While his colleagues chased exotic refrigerants, Carrier's first working machine was built around something almost embarrassingly cheap, a common industrial salt called calcium chloride. Factories practically gave it away. What made it remarkable was its appetite for water. A pound of it could absorb roughly its own weight in moisture and rip the heat right out with it. In 1902, Carrier got his proof of concept. Working for a Brooklyn lithographing company called Sackett and Wilhelms, whose color print runs were being destroyed by summer humidity, he completed a system on July 17th that sprayed chilled calcium chloride brine through the airstream of the factory. No compressor was ever installed in that first design. Records show the print plant ran on salt brine alone for nearly a decade. But Carrier kept noticing the part nobody had asked for. The salt was not just drying the air, it was cooling the room. Buffalo Forge did not reward him for it. Remember that? We're coming back to it. Here's the number that changes everything. To raise 1 pound of water by 1 degree, you need about 1 BTU of heat. That's the baseline every cooling engineer works from. But when 1 pound of calcium chloride absorbs water vapor from humid air, It pulls over 400 BTU units out of that air while its own temperature barely moves at all. Engineers call this absorption cooling. The energy does not warm the salt. It goes into the chemical bond between the salt and a water molecule, locked away in the reaction. Pound for pound, a tray of this salt can strip the felt heat out of a humid room faster than a window unit running at full load. Now think about what that means in an American July. 90 degrees with 80% humidity feels like 105 because your sweat cannot evaporate. The salt sits in your room, completely inert in dry conditions, doing nothing, costing nothing. Then the humidity rises. The salt reaches its threshold, and it begins to absorb, pulling the moisture and the heat out of the air at exactly the moment you need it pulled. The thermostat is not wired in. It is built into the chemistry itself, and the cycle resets. Set the saturated brine in direct sunlight. The water evaporates back out, and the salt recrystallizes, ready to absorb tomorrow's humidity. A solar rechargeable cooling battery for the price of a pizza. So the only question left is whether it performs in real buildings. It does, and the numbers are on record. Start with the Sackett and Wilhelms plant itself. Records show it ran on calcium chloride brine alone for nearly a decade, controlling humidity in a 30,000 square foot factory through Brooklyn summers. In 1902, an industrial building carried its entire climate load on a chemical that cost less than the ink it was protecting. Now jump forward to modern data. Published field trials measured what liquid desiccants do to a building's cooling demand. The findings repeat across studies. Indoor humidity drops by 20 to 40%, and cooling energy falls by 30 to 40%. Not laboratory projections. Instrumented buildings monitored across full seasons. The National Renewable Energy Laboratory ran liquid desiccant systems using calcium chloride solutions, blending them directly into commercial HVAC retrofits. A study published by MIT Technology Review in 2010 confirmed that desiccant systems could transform cooling efficiency in any humid region, shaving peaks silently with no refrigerant cycle. And the cost comparison is almost unfair. Calcium chloride is measured in dollars per pound at any hardware store. A central air system is measured in thousands per home, before electricity, before service contracts, before the replacement 15 years later. A bag of road salt versus a $29 billion a year cooling industry. So if the data was this clear over a century ago, where did it go? The answer starts with what happened to Carrier's first invention. Salt brine could not be patented. What could be patented was a mechanical compressor cycle using a proprietary refrigerant inside a proprietary machine. In 1906, Carrier filed exactly that patent. Records show the original calcium chloride design was quietly dropped from the product line. Not because the physics failed, because the institution chose a different product. Post-war America was about to make a decision of its own. Utilities launched the Live Better Electrically campaign, backed by General Electric, Westinghouse, and hundreds of power companies. Modern meant plugged in. Then came the window air conditioner. Within a decade, Americans were buying over 1 million units a year. Cooling stopped being a property of the building and became an appliance. A box you purchase, a box that breaks, a box you replace. The salt didn't fail. It was outsold. And once the market chose the compressor, the rulebook was rewritten to match. Cooling systems today are sized under a procedure called Manual J, built entirely around mechanical equipment. The inspector's checklist assumes a compressor. A tray of desiccant salt has no line on the form. It isn't banned. It simply doesn't exist in the paperwork. And underneath all of it sits the quiet math nobody says out loud. A desiccant tray has no refrigerant to refill, no service contract, no 15-year replacement. The average cooling customer is worth over $15,000 across a system's lifetime. A bag of calcium chloride is worth $15. But none of this stops you because calcium chloride doesn't need a permit. Start with what you can buy today. Calcium chloride pellets, sold as ice melt in every hardware stores. $15 for a 40-pound bag. Shallow trays covered with breathable mesh, placed in the hottest corners of a room. One documented case in a Gulf Coast climate dropped indoor humidity by 20% in 24 hours using nothing but salt trays and a single box fan. But here's the rule that makes or breaks all of it. The salt must reset. Direct sunlight, a warm attic, no drying cycle, no recharge. And now the honesty you won't hear from anyone selling these products. In dry climates, the Southwest, Arizona, Nevada, the air has no humidity to absorb, and performance collapses. This technology shaves humid heat. It does not replace air conditioning in dry, extreme heat. Where it shines is the Gulf Coast, Florida, Texas, the entire eastern half of America in July. Stay with me because the last part is the reason this still matters. The Sackett and Wilhelms plant is long gone, but the chemistry inside it never stopped being true. Spanish apothecaries lining storerooms in the 14th century, Mughal physicians cooling royal bedchambers, English sea captains protecting cargo holds in 1650. A 25-year-old engineer in Brooklyn proving the chemistry in 1902, and then watching his own company file patents that buried it. And the National Renewable Energy Laboratory today rediscovering what Carrier already knew. Different centuries, different continents, the same mineral. Every one of them arrived at the same answer because the answer was never a matter of opinion. Calcium chloride absorbs over 400 British thermal units per pound. It did so in 1902. It does so today. And it will still do so long after every compressor ever built has rusted into scrap. No committee can repeal that. No rebate form can repeal it. Willis Carrier died in 1950. The company outlasted him, but his first invention outlasted their patents. The knowledge was never lost. It was just never handed to you. Now you have it. So drop your state in the comments and tell me your summer humidity. Because that one answer decides whether this works on your house. And if you believe real chemistry keeps getting buried to protect someone's quarterly earnings, hit subscribe. Because next week I am covering the copper coil cooling system Edwardian engineers used to air condition entire hotels in 1898, and why modern HVAC manuals quietly stopped teaching it.